All right, today we're going over a centrifugal pump for our acting engineers that are opening up their acting engineer PTB. We're going to be going over what a centrifugal pump is because that's what we have on all our frontline engines and trucks. So I'm going to draw a diagram and explain some things here, and then we'll go out to the fire truck and show some things out there so that we can get some visuals on things. And we'll be open for some questions as well as interaction and engagement. So, all right, so here we go. So centrifugal pump is we have a couple things here. We have so this is going to be the eye here, right in the center, and that's where our intake goes right into the pump. This is going to be right here as it spins. The water spins outwards is the volute. These things here that spin around is the impeller. Here is our discharge. So discharge, eye, impeller, volute, and the idea behind a centrifugal pump is the spinning of the water creates centrifugal force. That's why it's called centrifugal, and it spins the water, and the space of the casing, this is also called the casing right here, right on the outside. The spinning of the water as it increases in diameter from the center outwards creates the pressure. So the faster that the impellers are spinning, the more pressure we have. The bigger the pump is itself, the more pressure we can have. So if you see the centrifugal pumps that we have on our brush trucks, they can pump 200 GPM, 250 GPM, and they're about this big. You'll see them on the backs of our brush trucks. And then on our frontline engines, we can pump 1500 GPM, and those are about this big around in diameter. So you can see from here, the water's coming out on the discharge, and it goes to all our different discharges. So our cross lays, our 2.5s, our deck guns are all coming off of this here. We have a tank to pump line. So let's see, I'll draw it here. Tank to pump. That comes down from our big tank in the fire truck with 500 gallons of water, and that comes down and into the center of the pump. So if we're running off of tank water, we're going to be using water from tank to pump, and our tank to pump valve will be open. If we're running off of hydrant water, we connect with our LDH, our 4-inch, and comes in, and it goes right to our intake, which goes right to the center. So this would be hydrant water going right into the center of our pump. On the other side of our pump from the intake, we have our transfer case from the drive engine, and that comes up and actually powers on the other side the spinning. So all the power of our pump comes from the motor of the actual engine. So if you were to crawl under there, you'd see a transfer case that goes from the drivetrain all the way back, and it goes through this big transfer case. And so when we go into pump, when we switch from driving and into pump, it transfers that power from the train under to a drivetrain that then goes up into the center and spins our pump. That's why it's directly related to the RPM that we have. If you're looking and you can hear the RPMs of the engine are increasing, the PSI of our pump would be increasing. That's everything that we have in the components of the pump. Any questions?